We've managed to rebuild our B&M 250 that we got as a pile of parts on eBay, but of course, that's not the end of the story. We've seen that some of the components of that set were broken, but others were outright missing. And since this kit is decades old and the company that made it doesn't even exist in the same form anymore, they ranged from difficult to impossible to find. One that I couldn't get my hands on was the pop-off plate for the intake manifold. As parts go, the plate itself is a very simple one, but there are a few components that need to go along with it. We are going to need the plate, a gasket, springs, retainers, studs, and hold-down nuts. The purpose of all of this is to provide a less harmful exit path for excess pressure that might be built up in the intake manifold. Most commonly and most dangerously, this pressure would come from the fuel-air mixture in the intake manifold igniting, resulting in an intake backfire. There is a significant chance of damaging the supercharger if that pressure doesn't have somewhere else to go and the driven pulley can't slip on the belt to allow the rotors to freely spin. Since we're running a toothed Gilmer drive setup, slippage is not likely and we will definitely need a functional pop-off valve on the intake manifold. Though, since I was completely unable to find a plate for sale, we will have to make our own. We'll start off the old-fashioned way with a piece of paper and pencil. With this held in place on the manifold, we will make a rubbing of the part we're going to need. We'll trim the paper down to just an outline, use an X-Acto knife to cut out the center, and a punch to knock out the bolt holes. This gives us a template of the space that the pop-off plate has to fit within. We'll transfer that to a piece of cardstock, and from there, design our plate. This is what I came up with. It's pretty much like the actual part, though a bit more rounded on the lower side. The threaded mounting holes on the intake manifold are 5/16 by 18, which is mostly notable because this universal pop-off valve set that I purchased uses 3/8 of an inch bolts. It also included a gasket, which pretty obviously is not going to work for us. But that's okay because I really bought the set for the springs and retainers. I had heard of people using all kinds of things like valve springs to do this, but in this case I decided to go with something purpose-built. It would seem that our plate template should do just fine, so now we have to work on transferring that to metal. We'll trace it out onto a piece of 1/4 inch thick 6061 aluminum, center punch the bolt holes and drill them out to 11/32 of an inch, give those nice chamfered edges, and switch over to the angle grinder with an aluminum cutting disc to trace the lines we drew. Pretty soon we had a general shape to work with, which will then need its corners trimmed off. We'll finish up the shape of the plate by rounding everything over on the belt sander. To keep the aluminum cool throughout this process, we will periodically dunk it in water. It's not machine accurate, but pretty soon we had a shape I was happy with, and we will finish the whole thing off by smoothing over the sharp edges. With that done, we're almost ready for a test fit, but we'll also need the gasket to go underneath it. We'll trace our original design template onto some fiber gasket material and cut out 2 copies, just in case. So now we have a gasket and aluminum plate that should be just the right size. To mount that, we have these 2 3-inch long 5/16 by 18 stainless steel studs. Over top of those, we can slide the springs, retainers, and the washer since the retainers are made for 3/8 of an inch bolts. We'll go ahead and tighten those down some. We probably won't need a whole lot of tension on these when actually running our system since the supercharger won't make a whole lot of boost on this engine, but we do want to make sure everything moves freely. Which it's a good thing we tested because they don't. Here you can see that the spring is binding up on the intake manifold bolt head. It's not super jammed up, but we still don't want that happening. You can see a bit of paint chipped off right where that retainer was hitting. This is probably because of the 1/8 inch thick washers, and if we just switch those out for 1/16 of an inch washers, hopefully we won't have any more clearance problems. To make things just a touch easier to install and remove, we'll also trim down the studs by 3/8 of an inch. Hopefully that's all of the kinks worked out and we are ready for final assembly. With anti-seize applied to the intake sides of the studs, we'll get those threaded in. Then on go the spring, retainer, washer, and nut assemblies. As far as how tight these should be, I'm completely guessing, but we're gonna start on the loose side, because worst case scenario we end up with a bit of a boost leak. I'll probably end up messing with the tension later on, but for now, at least everything is together. And yes, the springs are still a pretty tight fit, but at least now they're not binding on anything. The pop-off valve is a very important item to cross off the list, but it won't be doing very much if we don't have a belt to turn the supercharger over. The kit I had purchased didn't include one, but kind of amazingly, I was able to find a used belt on eBay. Finding this was a decent stroke of luck since it is a pretty obscure part, and it was only $25 plus shipping. It's definitely been used, but it looks to be in good shape and hopefully will last a good while. Though, perhaps the most useful part of this purchase was the part number. Once I had that, I was able to look around, and about 6 months later, this popped up on eBay and cost even less than the used one. Now we have 2 belts for our setup, and we have a number to look up in case we need another in the future. So, how are we getting power into and out of that belt? We've got the 2 pulleys that came with the supercharger, a 45 tooth upper and 72 tooth lower, and I also picked up this 55 tooth just in case we want to slow things down a bit. Decreasing the number of teeth on the upper pulley and increasing the number of teeth on the lower will change our drive ratio and make the supercharger spin faster at a given engine RPM. I figured it would be better to take it easy on the engine and drivetrain of the car for right now, and it might be a little bit easier on supercharger components as the Teflon strips break in. Our set of parts for the belt drive system is coming along nicely, but there's still a very big piece missing. That would be the entire idler assembly, which is pretty important for putting tension on the belt, so we will need to figure that out. And if finding that used belt on eBay was lucky, this felt like winning the lottery. It's the exact pulley that would have come with one of these kits, and I have never seen another one for sale. And yes, I could have gotten a pulley for a different supercharger and made it work, but many of the aftermarket ones are for 3-inch belts and or have a smaller pulley diameter, which would mean our belt length would change, and of course wouldn't be nearly as cool as having the matching pulley for our setup. Which, even with that B&M idler, is still a bit lacking. We still have nothing to bolt that pulley down to. It's supposed to sit on a bracket and set of spacers that are attached to the intake manifold. And unfortunately, our part finding luck had run out because there was no way to source those. I even had a lot of trouble finding good pictures of the setup, and most of the ones I could find were of the small block version of the kit, which according to the Y-End catalog has a different part number. I'm not sure if the standoff length is the only difference or if the bracket itself is different, but either way I didn't want to rely on those for estimating the dimensions of the bracket. Though, as it happens, long after the events of this video, I ran into a B&M 420 on a big block Chevy at a truck show. I'm not 100% sure, but I think this bracket and its standoffs are the same as the one used for the 250. In later models, they even shared the same intake manifold. I didn't have a ruler handy, but the owner was kind enough to let me take reference pictures with an object of known size that I just happened to have on hand. From there, I was able to figure out the actual dimensions of the real B&M bracket, which I'm going to list here just in case they could help somebody else. Back during the events of this episode, I didn't have this information and we were going to have to wing it to make a bracket. But before getting into that, we'll also need standoffs, so let's figure out how to make that happen. Initially, I actually tried to make this easy and bought this set of 4 5/8 outer diameter, 3/8 inner diameter steel spacers, but of course we don't really do things easy around here, and after these were in front of me I decided I wanted 3/4 of an inch outer diameter spacers, which I wasn't able to find, and I wanted the option of using 5 instead of 4. So, starting with these 3/4 inch rods of 6061 aluminum, we will be fabricating our own. We'll measure out 4-inch sections of those and use an aluminum cutting disc on the angle grinder to cut them to length. I came up with that 4-inch number through measuring and test fitting and guessing, so hopefully that all works out. Once those have been sectioned and measure out to just over 4 inches, we'll need to sand them down to make them all even at 4.00. The best method I've found for squaring those ends off is spinning the dowel round and round against an angle fence in the opposite direction of the spinning disc. And pretty soon, there we have it, 4.00 inches on what I'm sure are highly accurate calipers. We'll chamfer the edges just a bit to get rid of any burrs, and it's on to the next one. We'll run through this process for all of our pieces, and pretty soon we've got 5 matching blanks. Of course, they're not spacers just yet, and that's going to require quite a bit of drilling. With me just holding onto it to keep it from rotating, we'll drill as far as we can with a 3/8" drill bit, until inevitably it got to a point where I just couldn't keep it still. Then we'll take that over to the vise, and using the power drill and a 13/32 drill bit, we'll try to go down past the halfway point through the 4-inch section. The idea being that the drill press should drill a relatively straight hole, but I don't really have a good way to hold it down, so we will finish, the first half of it at least, in the vise. And once we're there, that same piece is going back to the drill press where we will start from the other side. Once again, I'll hold it still as best I can until there's enough depth that we should be able to drill straight through in the vise. We'll run the bit through both sides to clean up the transition in the center, and there we go, a 3/8" bolt slides nicely all the way through the spacer, and it seems like we're in pretty good shape. Except, of course, we need to do that 4 more times. I didn't particularly enjoy any aspect of drilling through 20 inches of aluminum, but the worst part by far was trying to hold the pieces still in the drill press, and I really wish I had just engineered a better way to do that. But here we are, we're done. We've got 5 spacers that fit our 5 mounting bolts, and while they're not perfect, I think they're going to be good enough to hold that bracket on securely, which we will find out after we build it. Just like we did for the pop-off plate earlier, this all starts with a pencil rubbing. That gives us the accurate positioning of the bolt holes, which is a major component of this bracket, but we still need hardware to hold the idler pulley down to it. I went out and bought one of these generic idler pulley mounting kits because it was the cheapest way I could find to get one of these special backing nuts. We won't be able to use that pulley standoff, and the bolt is too short, but we did get what we needed. And now that everything's in hand, we'll start by making a paper template. We'll be basing this off of the pictures I was able to find of these brackets, but there are going to be a few modifications. First off, to better fit the generic backing nut, the slot will be centered between the bolt holes instead of offset towards the top. The original part had a flat section to accommodate the bolt spacers, and we may as well just modify our design to fit the parts we have. We'll also be adding a 5th mounting bolt hole for a bit of extra rigidity, largely because we will be making the slot longer. The main reason for this is that 55-tooth lower pulley that is so much smaller than the 72 that we'll need a lot of idler adjustment range to run the same belt for both. The secondary reason for this longer slot is that I didn't have exact dimensions for the bracket, and, well, I didn't want to have to make it twice, so we may as well have a little bit of extra wiggle room there. This design went through quite a few iterations before I finally settled on one that we will transfer over to this piece of 1/2" 6061 aluminum plate. We'll trace the template with Sharpie and make a few extra marks to ensure that that slot is centered and evenly spaced between the bolt holes. From there, we'll drill a pilot hole at either end of the slot with an 8-inch bit, which we will follow up with a 3/4-inch spade. I have found that these work really well for aluminum, and they did great here. We're using the shop vac to cut down on some of the debris, mostly to make it easier to see what we're doing. Pretty soon, we've gone all the way through and have the first of the slot ends drilled out. We'll repeat that same process for the other end, which goes just as well. Drilling out the edges like this not only gives us nice smooth curves on the outsides of the slot, but gives us start and end points for finishing it off with the angle grinder. To help us do that accurately, we'll erase the old lines with brake cleaner and draw some new ones connecting the outside edges of those holes. We'll trace over those with an aluminum cutting disc on the angle grinder, making sure to take it nice and slow. Once the first side is cut all the way through, we'll repeat that same process for the second, but there's still a little bit holding that center island in place, which we will finish off with the saw. And there it goes. We will definitely need some finishing work, but the slot is cut out. We'll work our way around its outer perimeter with a file and make sure the T-nut can slide fully end to end. We'll also remove any burrs and slightly round over those sharp cut edges. The final product is hardly perfect, but it is entirely functional. The finished slot is 6.5 inches long and gives the idler pulley 4 5/8 inches of adjustment range. Now all we have to do is trace the outline and cut the part out from the rest of that plate. Eventually, everything we didn't need was gone, and this is what we were left with. It's not exactly handsome and is going to need a lot of cleanup, but that's what the belt sander is for. There was a lot of material left to be moved and some pretty long straight edges, but after all of that work, this is what we came out with. The last big part of this is going to be drilling out those mounting holes, which should be pretty straightforward, but to help us do so accurately, we'll be making a set of cheap but effective tools for the job. The first step is to cut the heads off a couple 3/8 coarse thread grade 8 bolts. Next, we'll chuck one of those little bolt stubs into the power drill and take it over to the belt sander. With the drill spinning in the opposite direction of the belt, we can pretty quickly form a pencil tip point at the end of that stud. Now we can repeat that process 4 more times. And after a bunch more sanding, we're left with this set of 5 transfer screws that we're going to use to accurately mark out our bracket. Those will get threaded into the intake manifold, and I'll try to get them all to relatively the same height. Now all we have to do is lay the bracket over top of those screws. Then, to accurately transfer the center of each of those bolt holes, we will give the bracket a smack. And since we've got nice clear marks from each of those transfer screws, it seems like we won't have a whole lot of excuses if we don't get those aligned. Once all 5 of those have been piloted, we'll switch up to a 25/64 drill bit, which will give our 3/8 inch bolts a little bit of extra room. With those taken care of, the final operation is to use a 3/4 inch countersink on the front face of each one. We'll take that all the way down to just a bit below the surface so that the bolts can sit flush. Once the bolts are tightened down, the bracket shouldn't be able to budge even a fraction of an inch. With the front of the bracket finished, we'll chamfer the back edges of each of those bolt holes and get the intake manifold ready for a test fit. We'll install each bolt through the bracket, then the spacer, and into the threads in the intake. Once those are all in place, we'll start snugging them down one at a time. You can definitely see how the countersink helps precisely locate the bracket, and with these just hand tight, it isn't going anywhere. It even passes the final test, which is making sure that the backing nut can move through the full range of the slot. A lot of research and planning went into making this part, but it seems like it paid off because the bracket is doing exactly what it's supposed to. But of course we can't be completely sure that the fitment on there is correct until the supercharger and idler pulley are both installed. The full assembly will have to wait for a later episode, but right now we can do some work on the idler pulley. While I was incredibly lucky to be able to get my hands on this thing, and it does seem to be in decent shape, it is still old. So, just like we did for the supercharger itself, we'll be opening this pulley up. We'll get that started by removing the 6 socket cap screws and lock nuts around the inside of the pulley. But even with those out, the whole assembly is still very much together. To take it apart, we'll grab a 2-jaw puller, and with that hooked on the outside edge of one of the pulley halves, we can start tightening down the main screw. After only half a turn, it was clearly starting to move, and we were able to split that pulley in half. Now that we can see inside of this assembly, it's pretty clear how it's put together and shouldn't be too difficult to take apart. We'll start by using snap ring pliers to remove the retaining clip at the end of the spindle, but those greasy bearings are clearly a tight pressed fit, so we'll go back to the 2-jaw puller and remove the other half of the pulley. This worked super well and came off just as easily as its counterpart. Now we can see the entire assembly and use the puller to remove the bearings. At least I tried to, but they were really on there and I decided to just use a pry bar and hammer to knock them loose instead. We'll go back and forth to get the bearing moving, and once it has, we'll go back to the puller to finish extracting it. That top bearing came right off, and we'll reposition the puller onto the lower bearing to remove it as well. There was some elbow grease required, but the mission was eventually a success. Now that the idler pulley is fully apart, we can clean up its components and order some new bearings. After taking a closer look, it appears that that spacer in between the two bearings was cut from a standard piece of black steel pipe. And the finish on the inside bore of the spindle leaves something to be desired. It kind of looks like a part I made. But that sketchiness aside, it worked once and should work again. Although, in order for the idler pulley assembly to work, it's going to need a central mounting bolt. From the factory, this would have been a cap screw that required a hex socket, but since this bolt is something that might need to be messed with on the side of the road at some point down the line, I really wanted it to be a standard hex. To use a hex bolt, it needs to be spaced up from the idler spindle, but of course I couldn't find a standard 5/8 washer that would fit the inner diameter of the pulley. In order to make them fit, we'll slide them over these 1/4-inch SAE washers and then install those on a bolt. With a few nuts as spacers, we'll tighten that down and chuck it into the drill. Right now those washers don't fit in the pulley at all, but that's why we're sitting here at the belt sander. While spinning the drill in the opposite direction as the belt, we will grind away at those washers until they do fit through the pulley. A bit more sanding gives us the wiggle room we're looking for, and these are the modified washers that we're left with. They're exactly 1 inch in diameter and fit nicely under the head of a 5/8 of an inch bolt. Those will get a quick spritz of paint, which will hopefully prevent the exposed steel from rusting. We'll also give a quick coat of that cast aluminum engine enamel paint to the base of the spindle and the bearing spacer just for fun. The pulley itself will be leaving in a bare aluminum finish, but we've got to first clean off the grime and then polish them inside and out with WD-40 and Scotch-Brite to get the pulley halves looking nice. With those all shined up and a pair of new bearings to install, we are ready to put the idler pulley back together. The bearings are a different size than anything else used in the Supercharger, but at least it's a common size, so they weren't hard to get. To help those install onto the spindle, we'll apply some engine oil to its outer diameter. Then, using a 1 1/16 inch GM oil pressure sender socket, because it fit just perfectly over the thing, we will hammer that first bearing into place. After that, on goes the pipe spacer, and then the second bearing. Once it's bottomed out, we can reinstall the retaining clip. That will keep the bearings in place nicely as we reassemble the pulley around them. With the inner diameter of the pulley halves oiled, we'll drop the rear one into place and bring it over to the vise. We'll place a wooden board against one jaw and this piece from our ball joint press kit against the other. This takes a decent amount of force, but it does work, and pretty soon the pulley half is shouldered up against the bearing. That's the first half in place, and we'll repeat that same process for the front of the pulley. This time, with just the vise, it was difficult to get the bearing to go in straight, so we'll help it out with a pair of clamps. Once the two halves are firmly back together, we'll get the pulley assembly back on the bench and reinstall the 6 bolts. We'll add on washers, lock nuts, and get those all snugged down. Finally, they'll get torqued in a crisscross pattern to 100 inch-pounds. And there we have it. That is the idler assembly for our supercharger setup, rebuilt, refinished, and ready to install. With that done, our supercharger setup is basically complete. But we've still got quite a few things left to work out before we can bolt all the supercharger stuff on and see if it actually works. So next time, that's where we'll start.